Welcome back to Shiksha DaCosta. Today we're going to be looking at the applications of acute triangle trigonometry. And this is the last lesson in applying the sine and cosine law in acute triangles. As part of this lesson, we'll learn how to use acute triangle trigonometry in various careers, or how it's applied. And of course, you're successful at these skills when you can solve problems that arise from real-world applications involving both metric and imperial measurements, and when those applications also require you to use the sine or cosine law in acute triangles. To get our minds in the right groove, let's look at this popular scene that you might encounter in your daily life. If you work for an evil dark lord and you're one of 9 evil henchmen that are trying to capture an elf on the far side of the river, I know, in a situation that we find ourselves in almost every week, right? But the elf witch calls forth some water spirits to protect her. And from the side, you hear the rush of water, and the water spirits are coming to take out you and your colleagues. Well, can you make it over the river and back? If your horses can gallop at 64 kilometers an hour, and the water spirits will reach you in just about 5 seconds, should you try to go ahead and get the elf? Suppose you're standing all 9 of you are standing 4 feet apart. Well, this is a situation where some quick trigonometry can help you bring that elf back to your dark lord and master. Suppose this is the situation you find yourself in. Here are the 9 of you, and there is the elf on the far side of the river. The henchman on the right sees the elf at a 40-degree angle, and the henchman on the left sees the elf at a 54-degree angle. Remember, you're standing 4 feet apart, and so the total distance between the first and the last person is 8 times 4, or 32 feet. Okay, 1, 2, 3, 4, 5, 6, 7, 8. And we can use this situation creating a sort of triangle out of it. And now we can start to work to find out how far does this henchman have to travel? How far does this henchman have to travel to go get that elf? Can they make it over there? First, when we're looking to whether we can use the which strategy is the best trig strategy to use, we notice that this is not a right angle triangle, and so Pythagorean theorem and our trig ratios are out of the question here. Instead, we have to realize, can we use sine or cosine law here? Well, I don't see a pair, right? This angle, I don't have the opposite side. For this angle, I don't have the opposite side. And for this side, I don't have the opposite angle. So I can't use sine law yet. I don't have 3 sides, so I can't use cosine law. And I also don't have 2 sides with an angle in between, so I still can't use the other version of cosine law. So what do I do? I think between the 9 of us, we can put our heads together and figure out that, first, if we can figure out this angle, which is actually pretty easy, right? All of these need to add up to 180 degrees. If I can find out this angle, then I will have a pair, and then I can use sine law. So I know that 54 degrees plus 40 degrees plus whatever this is, we'll call that theta, they all add up to 180 degrees. If I subtract 54 and 40 degrees from both sides, I'll get rid of them on this side, and then because I have to do the same thing to the other side, I can find out that theta is equal to about 180 minus 54 minus 40 is 86 degrees. And now I have a pair, so that allows me to use sine law. And I'm going to use it to try to calculate this distance right here. So sine law, all I need is a side and its opposing angle. So here I've got that, this side 32, and this opposing angle here 86 degrees. And that's equal to some other side and its opposite angle. So I'll say this here is side A, and this opposing angle here is 40 degrees. We want to find out what side A is, so we're going to try and isolate it. And we'll do that by multiplying by sine 40. That's the opposite of division by sine 40. And so those two will cancel themselves out. We have to do the same thing to the other side. And so we end up putting all of this into our calculator. And that will tell us that the value of A, the length of this side, is about 20.61 feet. And so I'll just label that there. The other side can be solved using, again, I can use sine law again. This time I'm actually going to use cosine law though, because I do have 32 and 26, right? These are two sides, and they have an angle contained in between. That angle is right here, and that helps me find the side length that I'm missing, the third side length over here, the one right across from the angle that I'm using. And this side, we'll call this side B. This is equal to the square root of all of this, right? 32 feet, 20.6 feet, and 54 degrees are my inputs to the cosine law. And that tells me that this length is about 25.95 feet, which I'm going to round up to 26.0. And there you have it. I found the distances here. Now, how do I use that to calculate whether or not these horses, these water spirits, are going to get here in time? Or whether me and the homies can get there, grab the elf witch, and escape. Well, our horses can go 64 kilometers an hour at their full speed. And that's pretty fast. Is that enough to get there? Maybe even get back? Well, we have to do a little bit of work here. We're gonna have to, we measured our distances here in feet, which is an imperial measurement, but the speed we know is in kilometers, which is a metric measurement. So we just have to do some conversion work. I'm gonna convert 64 kilometers. How many feet would that be? Well, that would be, if I just quick Google 64 kilometers to feet, that tells me that the formula to get from kilometers to feet, all I have to do is multiply it by 3,281. And it also gives me that measurement here as well. So 64 kilometers is actually 209,974 feet. So clearly more than this. But I don't have a full hour, right? This would be how much time I had in an hour. I don't have an hour. I only have 5 seconds. So how do I convert this to seconds? Because we also want this in the same unit. I'll just Google that again. 1 hour to seconds. And that tells me that that would be, I would cover this much distance, 209,000 feet, in 3,600 seconds. I don't obviously have that many. I only have 5. So we'll have to do some work with rates here. If I divide these two, I will find that my horses my horses can travel 58.3 feet in 1 second. And because I have 5 seconds, I know that we will be totally safe. We'll be able to cross 26 feet, no problem, and another 26 back. And I'll still have 3 seconds, more than 3 seconds to spare before the horse spirits get here. And hopefully we can grab the elf and bring her back before, and that there's not too much of a struggle, and our Dark Lord and Master will be very, very pleased. The elf, unfortunately, will be less than thrilled. And there you have it, folks. That's how you can use trigonometry to measure distances in real life. You can use it to measure distances that you can't physically reach. Surveyors or cartographers might also use it to measure the width of rivers, roads, or canyons, or other obstacles in their way. Carpenters might use it to measure distances for furniture or lengths for buildings that they're building. When you're going through this, you might come across terms like angle of elevation or angle of depression. An angle of elevation is an angle between a horizontal line and a line that's pointed above it. So that angle right there is your angle of elevation. Whereas an angle of depression is an angle between a horizontal line and a line that is pointed below it. So right there, that's your angle of depression. If you like this video, please like, rate, subscribe, and join our mailing list. And you can find this lesson as well as practice questions, solutions, handouts, and more on our storefront. Thanks and have a great day.